and air circulation is quite important. WHO has announced that the spread of COVID-19 can be transmitted by air.
To measure the speed of airflow, we need an anemometer, but common anemometer can only measure airflow speed starting from 1 meter per second, which is too high for this purpose. For this reason, we created an improved ping pong ball anemometer that had been modified to become more sensitive to airflow speed measurements so that it can produce values below 1 meter per second.
The anemometer consists of one ping pong ball mounted on a straightened paper clip. At one side, the metal plate was placed so it can be detected by a photointerrupter. There are two principles that apply to this anemometer, which is turbulent force and the balance of rigid objects. When the airflow goes from this direction, it will cause a turbulent force that will make the system rotate. Therefore, a coil was installed on the lower left to pull the system back into balance.
When there is no barrier, the photointerrupter will produce a large signal, but if the metal plate is blocking the light, then the signal will become smaller. It will be read by the processor and then processed by the PID controller, so it becomes pulse width modulation value to regulate how much current will flow to the coil and produce a magnetic force on the bolt. The method to measure the airspeed is by using smoke, a laser, and mobile phone to record videos.
This is the graph for 3 to 12 volts of power supply. The average wind speed is between 18 to 47 cm per second. This is the process when we were testing the anemometer in a wind tunnel. Average data is taken 10 times for each voltage setting, with one measurement is an average of 1000 data calculated by the Arduino.
The results are shown in this table. Voltage belongs to the commuter fan. S is the average obtained from the Arduino. S minus S0 is the system output that has been subtracted by the 0 point. F is the turbulent force obtained from this equation, while RE is Reynolds number and the value is around 500 to 1300.
From the data, a graph can be made. X-axis is the wind speed, while the left y-axis is the turbulent force and the right y-axis is the system output. It is also shown that the system produced a linear output with the turbulent force. It can be seen from its similar graphic form, namely parabola. From the result, we calculated the accuracy of the ping pong ball anemometer is 6 cm per second and the accuracy error is 1.4 cm per second.
That is our conclusion. Thank you for attention.